In exercise 3.3, we take a look at determining linear equations. Now, before we begin, it's really important to know that you must find the gradient m before the y-intercept c. What does that mean? Well, whenever we're calculating the gradient, it's going to be very hard to find the y-intercept without the gradient, which is a coefficient before the x. How do we find the gradient? We need two coordinates where we have x1, y1 and x2, y2. If we have this little diagram on the right, we can see x2, y2 and x1, y1 as points B and A respectively. If we find the run and the rise, and then we go the difference, rise divided by run, we can actually find our gradient or our slope. Okay, using the formula, the B coordinates y value take away the A coordinates y value divided by the answer of the A coordinates, the B coordinates x value take away the A coordinates x value. Okay, represented by y2 take y1 divided by x2 take x1. Now the higher point is always going to be x2 and y2. The lower point, or the point that's lower in the Cartesian plane, is always going to be y1 and x1. Okay, that's just for your reference later on. Let's take a look at an example. So in example 1, the question tells us to find the equation of the straight line shown in the graph. Now, what we notice here is we have to go about finding our m first. So our m is going to be, well, the two coordinates. Actually, let's label these coordinates. So the higher coordinate, that's 0, 6, because the x, it's on the y-axis, so the x value is 0. This coordinate here is going to be 3, 0. Now, if we look at our formula to find the gradient, y2 take y1, x2 take x1. The higher one is always going to be x2, y2, and then the lower coordinate is always going to be x1, y1. So our gradient is going to be, remember, y2 take y1 divided by x2 take x1. Now, if we plug in our values from the graph above, what we notice is y2 is going to be 6 take away y1, which is 0, divided by x2, which is 0, take away our x1 value of 3, and what we're left with on the top is 6. So the value on the top is 6, the value on the bottom is -3. 6 divided by -3 gets us -2. So what does this mean? Well, what we figured out is in our equation y equals mx plus c, our m value is going to be -2. The plus c, we actually have a shortcut here. The plus c is always our y-intercept. And if it gives us a y-intercept, we can automatically say, well, we don't need to use any fancy equation to go find it. It hits the x-axis at 6 or +6. We can say the plus c is going to be +6. Okay, just like we figured out, well, not just like how we figured out the gradient. All right, so our line's final equation is y equals -2x plus 6. In example 2, it once again says find the equation of the following straight line in the graph. Wow. What we notice straight away is our y-intercept is 0, so it's going through the origin. So therefore, it means we're not going to have a plus c, but we are going to have a gradient. Now, there's actually a shortcut with these ones, but I'm just going to show you the full way, just so we're consistent. We can say the rise is 1, the run is 2. Like we can say it's lifted up 1 and then the run is 2, but let's just do the proper way of the 2 points. So our 2 points are 2, 1 and 0, 0. So if this is our x2, y2, and this is our x1, y1, where both are 0, 0 because it's crossing the origin. Well, y2 take y1, we know this is going to be, well, let's just write the formula. We know y2 is 1. We know y1 is 0 because the line's crossing the origin. We know x2 is 2. And then we know x1 is 0. So we get our rise run of 1 on 2. What does this mean? Well, therefore what we have is a situation of y equals mx plus c. We figured out the m is going to be half. So therefore we replace the m in the equation with half times x. And we know the plus c, well, this is going to go through 0 because it's the x-axis, the y-intercept is 0. So therefore our equation is just going to be 1 on 2x without the 0. Example 3, here we're given just 2 coordinates. Okay, now we still have to find the gradient first, just like we mentioned in the important note at the very beginning of the video. Okay, m, remember, y2 take y1 divided by x2 take x1. Now we have to find the highest point to make it x2, x1. X2, y2. So we look at the y values of the 2 points. Here we've got 5 versus -1. We know that 5 in the Cartesian plane is much higher than -1. So we can say this here is going to be our x2, y2. And then this here is going to be our x1, y1. Okay, because a higher point we always want to have as x2 and y2, and our lower point as x1, y1. So what we do is we therefore go and substitute these coordinates in. So our y2 is 5. We go 5, take away y1, which is -1. So 5 take -1 divided by our x2 of -2, take our x1 value of 1. And therefore 5 take -1 gets us 6. Okay, because 2 minus next to each other is plus. -2 take 1 gets us -3. So we're going to have a negative gradient, and therefore m is going to be -2. Once again, we write down our equation of y equals mx plus c, and we can say therefore y equals -2. Oop, wrong one. Y equals -2 x plus c. What you notice now though, without the graph, we actually don't know where the y-intercept is. So what you do, take either point, whichever's easier. So usually if you have anything with 1 in the point, you'd probably go with that one because that's going to be easy to substitute in. Remember, in the y equals mx plus c formula, the y and the x are for substituting coordinates into. Okay, so to find c, what we need to do is to plug in, let's say, the 1 and -1 coordinate. You can plug in either, but I'm just going to go 1 and -1. So our lower coordinate for this example, it'll both give us the same answer if I plug in -2 and 5, but 1 and -1 is just a lot easier to do arithmetic with. So y would be -1, okay, because that's our y coordinate, equals -2 times our x value of 1 plus c. If we do linear equations and get c by itself, we can actually get our c or y-intercept value. So here what we have is -1 equals -2 plus c. So therefore, if we were to take, plus 2 on both sides, we would have c by itself. So -1 plus 2 would equal c. So therefore, 1 equals c. So what does this all mean? Well, our answer to our equation is therefore y is going to equal -2x plus 1, because we found our c value as 1, and we just plug it back into the equation from above, which we didn't have the c value for, and we replace the c with +1. Example 4, finding the equation when the gradient is known. Well, this one's super straightforward. So they tell us find the equation of the straight line with a gradient of 2 and a y-intercept of -5. In our y equals mx plus c, we know that the gradient is always m, so we can just substitute 2 into the m. And then we know that the c value is always going to be the y-intercept. And instead of having a plus c, we're going to have a -5. That's it for example 4, nice and easy. Example 5, find the equation of the straight line passing through point 5, -1 with a gradient of 3. So it's really important that we highlight these information. So we know that our equation is generic, y equals mx plus c. They tell us the gradient is 3. So we can plug 3 into the m, and then we just need to find the c coordinate. Now we know a point, and that means we can use the y and the x in the y equals mx plus c to find our c value. So what we then do is we plug the points 5 and -1. So -1 would be our y value. Our x value is going to be 5. Okay, and then we're going to plus c. So therefore, if we do linear equation rules, we're going to go and get c by itself on the right side. So -1 equals 15 plus c. So therefore, if we were to take 15 on both sides, we are going to get c by itself. So therefore, 1 take away 15 gets us -16. All right. And what we now know is, I'll just keep working down actually. What we now know is from this equation up here, we can say therefore y equals 3x take 16, and that's going to be our answer. Okay, for the straight line. Sometimes you might get, a situation where they want you to convert ax plus by plus c form into gradient and point. And what you must do is a formula, y take y1 equals m brackets x take x1. Now the proof of the formula above, okay, if we have a diagram which shows a line of gradient m passing through the point x1, y1, okay, so here's x1, y1, here's our nice straight line. If xy is any other point on the line, this can be any point along the line, then the rise run of y take y1 divided by x take x1 is going to be the same as m brackets x take x1, y equals y take y1. Okay, and then we can flip that around and throw the y values on the left side and the left side to the right side. The formula y take y1 equals m brackets x take x1 can be used to write down the equation of a line given the gradient and the coordinates of one point. Now, some of you guys are probably going to ask, how did we get the situation? All we did was we times both sides by x take x1. Okay, and then we know that that would get rid of the x take x1 on the right side of the equal sign, and then we would have a situation of m times x take x1 on the left side. If you're unsure, please email through the question, and then I'll show you the proof in person. So example 1 here, it says, so we've gone back to example 1 because this is like a different segment. If we're converting into ax plus by plus c equals 0 when given a gradient and a point, to find the equation of the line with a gradient of -2, which passes through the point at 3, -4, write the equation in general form. That is in the ax plus by plus c equals 0. So what we would have to do is we underline the key information. So we know the gradient is -2 and we know there's a point. If you look at our equation m brackets x take x1 brackets equals y take y1, what we can say is this. We have our m value of -2. Okay, and then passes through the point 3, -4. It means we have one point, but not the other. So right now we can say we've got one point, but not any other point at the moment. So the point 3, -4 is at x1 and y1 value. So if we plug that in, what we have is a situation of x1 being the x value in the coordinate, which is 3, going to equal y take away the y1 value of -4. Now, once we've substituted these values in, what we can then do is go and expand out the brackets on the left side, where we have 2x plus 6, because -2 times -3 gets us +6. And on the right side, we've got y plus 4. The question tells us to write the equation in general form, which is ax plus by plus c, which equals 0. Essentially, where we don't have a y equals mx plus c, we're moving towards like a quadratic equation. Now, if we were to do that, we need to empty out the right side. Okay, so we need to have every term on the right side of the equal sign move to the left side, which means we'll have situation where we have -2x still on the left side. To get rid of this +4, we have to go and subtract both sides by 4, which gets us +2. Okay, because 6 take 4 gets us 2. And then this y here, if we're to get rid of, we have to minus y on both sides, which gives us a -y on the left side. Now, what you notice is it's always the x term first, the y term in the middle, and then the constant term last. So this must mean we have -2x take -1y plus 2, and this is going to be our equation in the general form ax plus by plus c. Hopefully that made sense. Let me know if it didn't. Now, here we have a real life example to finish off exercise 3.3. Okay, a printer prints pages at a constant rate. It can print 165 pages in 3 minutes and 275 pages in 5 minutes. Determine which variable is the independent variable and which is the dependent variable. So our X variable is going to be time in minutes, because that will not be affected by the pages we print. Okay, the amount of time we spend is going to affect the number of pages the printer is printing. So that means the Y is our dependent, which is pages. All right, the time unit we're dealing with is in minutes. Determine the gradient of the equation and explain what this means in the context of the question. So if we reread the question, a printer prints pages at a constant rate, meaning it's a linear relationship because it's constant. It can print 165 pages in 3 minutes and 275 in 5. What we need to think to ourselves is, well, what's the difference? So what's the difference between 275 and 165? Because we want to find out the rate of change per minute. Okay, if we find out the rate of change per minute, that's going to be our gradient, because our gradient, M, is always the rate of change. So 275 take away 165 gets us 110. So in other words, a printer prints 110 pages every 2 minutes. So let me just write this down. 275 take 165, which equals 110 pages in 2 mins. So therefore, per minute, we know that there's going to be 55 pages printed per min, because our gradient is the rate of change per minute. Our C value, our constant in the Y equals mx plus C, that's always our starting point. Okay, so what does this mean in the context of the question? Well, the printer is printing out 55 pages per minute. Based on the rates above, if we went 275 take away 165, and we know that there's 2 minutes of printing for that to happen, okay, which means we're printing 55 pages per minute. So here it says, write an equation in algebraic form linking the independent and dependent variables. So if we have a situation where we have, so write an equation in algebraic form linking the independent and dependent variables. So if we have a situation like this, what we have is Y equals mx plus c. We know that the M is going to be 55, okay, pages, which is our rate of change. And then to figure out the C, well, what we need to do is we need to substitute in one of these 2 points. So we can substitute 3 and 165 or 5 and 275. It can be either. So for this example, let's just pick 3 and 165 to find the C value, okay? Because that's the value that's missing. So what we need to do is we go 165 replaces a Y. Okay, the 3 replaces the X. And once we do this equation using our linear equation skills, we're going to figure out the C value. Let's just check if we got those right. Yep, that's correct. Hopefully we have enough space. So therefore, 165 equals, well, 3 times 155 is 165. Plus C. Therefore, if we take away 165 from both sides, we have 0 equals C. So our equation is Y equals What's our equation? Y equals 55x. All right. Which makes sense in this context. So a printer prints pages at a constant rate. It can print 165 pages in 3 minutes, 275 in 5 minutes. Okay, so basically we start at 0 pages printed when time is 0, is what this equation says. Okay, we're printing 55 pages when time is 0. So when it says to rewrite your equation in words, what we need to do is, well, we replace y with our variables. So pages is our y. Our y variable. 55 times time in minutes is our x variable. Okay, so this equation tells us how many pages the printer is going to print. Okay, it's just rewording the y and the x from the answer above. Using an equation, determine how many pages can be printed in 11 minutes. So, therefore, pages, okay, we got to replace the time here with 11 equals 55 times 11. So this is going to give us an answer of 605 pages, which is going to be what's printed after 11 minutes. Hopefully that all made sense. Let me know how you go with exercise 3.3, and I hope you're enjoying your quarantine. Thanks, everyone.